Before we can use the wood, we need a lathe to work with. The lathe is a machine that rotates the wood at speed so the turner can profile it to a specific design. During this process there can be considerable forces generated. So it is very important that the lathe be of a good, robust construction. The best material for a lathe is cast iron, which is heavy and dampens any vibration well. Vibration will take a lot of the pleasure out of turning. Ideally, the lathe should be able to turn up to a 10-inch diameter bowl. Because there will be different sizes of wood turned on the lathe, a minimum 4 speeds between 400 and 2000 RPM is recommended. The lower speeds will cater for large diameter work, and higher speeds the smaller diameter work. It should also have a good, rigid stand to support it. A lathe will consist of a headstock, which is the main working end of the lathe. This one features a swivelling head, which means that the headstock can be rotated to access any work fully. And if the urge takes us, we can turn big work with the aid of a large bowl turning attachment. The headstock houses a threaded spindle, to which various accessories can be attached to hold the wood when turning. Inside there is a series of stepped pulleys which are driven round by a motor and a belt. The speed that the spindle rotates is governed by the pulley that the belt is on. By moving the belt to a different pulley, we change the speed. We will look at speeds for turning later on in this video. On more expensive lathes, there can be a variable speed motor fitted. The benefit of this is that we do not need to change the pulleys to change the speed. Instead, the speed of the lathe can be controlled electronically at the turn of a dial. This will give an infinitely variable range of speeds within a defined band, for example 0 to 3000 RPM. The headstock is connected to a lathe bed of some sort. In this instance, the bed consists of round, solid, hard-chromed bars. The lathe bars act as a carrier for a Toolrest assembly, which is also made from cast iron. Into this assembly can be fitted a tool rest. This is the working platform or fulcrum point for the tools. At the other end of the lathe there is a tailstock. By rotating the hand wheel, the quill is advanced or withdrawn. Into this can be fitted various attachments. This is the unit that stabilizes the unsupported end of long pieces of wood for turning. In addition to these features, the lathe should have a well-constructed stand to support it. To work safely, the lathe needs to be set up to suit our height. This can be worked out by standing by the side of the headstock with our arms by our side. The centre of the spindle should be about elbow height. This height will afford us optimum tool control and keep us upright when working at the lathe. Good lighting is essential when turning. This can be from a window or strip lighting. There are basically two styles of turning. One is called between centre work or spindle turning. This is where the grain of the wood runs parallel to the axis of the lathe bed. Traditionally, this type of work is held between a drive centre or spur. There is a taper on the spur, which is known as a Morse taper. This fits into the headstock spindle, which has an exact opposite taper, allowing it to fit perfectly without slipping. And a revolving centre. The revolving centre revolves on a set of bearings, hence the name. This fits into the tailstock by means of a Morse taper. The wood is then held centrally between the two. Note the tailstock is locked just before the revolving centre touches the wood. The handle is then turned, which causes the quill to extend and force the centre to hold the wood in position. These support the wood as it rotates.